This homework solutions video is for Science of Mechanics, Unit 8, Heat and Sound, Section 1, Temperature and Heat. Number 1, how much heat energy does it take to raise the temperature of 750 pounds of iron from 80 degrees Fahrenheit to 600 degrees Fahrenheit? So in this problem, we're trying to find the heat energy. So Q is our heat energy, and that's equal to C, the specific heat of our material that we can find from a table, multiplied by M, the mass in kilograms, multiplied by delta T, which is the change in temperature. So the first thing that we're going to do is figure out what is that change in temperature. So change in temperature is final temperature, which is 600 degrees Fahrenheit, minus our initial temperature of 80 degrees Fahrenheit. So our change in temperature is about 520 degrees Fahrenheit. The next thing that we need to figure out is what is the value of C for iron. So to figure that out, we are going to look at our table of specific heat values. So for iron, that's at the very bottom of this table, its iron specific heat is 0.115. So Q is equal to 0.115 times our mass of 750 pounds times our change in temperature, which is 520 degrees Fahrenheit. So our value of Q, our heat energy, rounding to three significant figures right away, 44,900 BTU. Number 2, how much work must a person do to offset eating a 400-calorie brownie? So this is a 400 food calorie brownie, which is the same thing as 400 kcals or kilocalories. So in our notes, we talked that 1 kcal of heat is equal to 4,190 joules of work. So the amount of work that must be done to offset eating this brownie will be our 400 kcals. And now we have to convert from kcals of heat into joules of work. So we know that 1 kcal of heat is equal to 4,190 joules of work. So kcal over kcal cancel each other off. And then rounding to three significant figures right away, we end up with 1,680,000 joules of work must be done to offset eating this 400-calorie brownie.